All right, good morning or afternoon, depending on when you're watching this. We are going to take a look at solving problems using similarity and congruence. So you'll notice a lot of review in today's lesson. So first we're going to go over your warm-up. So you're told 3 buildings border a triangular garden. All right, we are taking a look today at solving problems using similarity and congruence. This will mainly be review, so we'll be reviewing some past concepts. Your warm-up, you're taking a look at 3 buildings border a triangular courtyard as shown in the diagram. A walkway runs parallel to the edge of the courtyard labeled CD, and that is a typo. It should be BD here, so that should be BD. And landscapers would like to install a picket fence along the outside of the courtyard with the exception of the walkway. The fencing comes in 8-foot lengths, and that's going to be very important a little later on. So this should be BD. All right, so that first question, it got cut off here, but we're asked to identify the similar triangles. Now keep in mind similarity can be defined in numerous ways. One example would be triangle CAE is similar to triangle BAD. Now this is using the triangle proportionality theorem to identify those similar triangles. Now we're told in 2, while preparing the sketch of the courtyard, landscapers forgot to measure the length of the courtyard, represented by DE. So we want to find the length of that. So once again, using the proportionality, we can state 410 over 164 is proportional to 595 over x, which is the length of DE. So cross multiply, so we get 410x, okay, then times 595 times 164, that will give us 97,580, and then divide both sides by 410. So our x value is 238. So the length of DE is 238 feet. And then we're asked how many sections of fencing are needed. Now keep in mind the fencing we're told in the original problem is around the perimeter. So we need to add all the sections up. So 410 plus 164 plus 238 plus 595 is going to give us a total perimeter of 1,407. And in the last statement of the question, we're told the fencing comes in 8-foot lengths. So we'll divide that value by 8. That gives us 175.875. Now the sections are sold in 8-foot lengths, so it's not we can buy 175.9, we're going to have to round up. So we would need to purchase 176 sections. Now let's go over some other terminology in the next part of your notes under the key concepts. So that first one is filling in the blanks. So similarity statements, true triangles are similar. So one we have is the angle similarity statement. Another one we've taken a look at is the side similarity statement. We've also taken a look at the side angle. And one other one we've also taken a look at is the side similarity statement. So just fill that one in. Similar triangles have corresponding sides that are proportional. Congruent triangles have corresponding sides that are congruent. So reviewing over those concepts. All right, next we have the three triangle theorems we've taken a look at. The triangle bisector theorem, triangle proportionality theorem, and then the Pythagorean theorem. So if the line divides one side of a parallel, if a line parallel to one side of the triangle intersects the other 2 sides of the triangle, then the parallel line divides these 2 sides proportionally. This is what we use in our warm-up. This is the triangle proportionality theorem. And then we have, if one angle of a triangle is bisected or cut in half, then the angle bisector of the triangle divides the opposite side of the triangle into 2 segments that are proportional to the other 2 sides of the triangle. Keep in mind, since an angle is bisected, this is going to be the triangle bisector theorem, or triangle angle bisector theorem, sort of a mouthful to say. And then that last one, written symbolically, a squared plus b squared equals c squared, that should ring off bells at this point, is often used to find the lengths of the sides of a right triangle, which is a triangle that includes 190-degree angle, so the Pythagorean theorem. So great refresher on theorems we've taken a look at most recently. All right, let's get into these 4 problems we're going to attack. So the first one, we're told a meter stick cast a shadow 65 centimeters long. At the same time, a tree casts a shadow 2.6 meters long. How tall is the tree? Now here we're going to do a sketch. So this is something we've taken a look at before. So since we have a meter stick, its height is 1 meter. Since it casts a shadow that's 65 centimeters long, in meters that would be 0.65 meters. And we're told we have a tree, here's our tree, cast a shadow 2.6 meters long. We want to know how tall the tree is. So we have similar triangles since we have at the same time. So we can set up a few different proportionalities. So we can do 1 over 0.65 equals the height of the tree over 2.6. Keep in mind both of the heights of our objects are in the numerators, their shadows, the distance of the lengths of their shadows in the denominator. Cross multiply, so we get 0.65x equals 2.6. Then divide both sides by 0.65. So our x value is 4. So we want to know how tall that tree is. It's going to be 4 meters since everything is in meters. So we're setting up proportions there. Once again, you're going to see a lot of review today. Number 2, we're told, and that got cut off on here, but it's on your paper, finding the distance across the canyon can also often be difficult. A drawing of similar triangles can be used to make this task easier. Use the diagram to determine AR, the segment across the canyon. So AR is the segment we're using. Now here we have similar triangles. So one thing you may find helpful is to sort of redraw the smaller triangles so that we know exactly what sides are going to be corresponding here. So if we want to redraw this triangle, we would have B, and then C, and then D would be at the top there. And so here are similar triangles. Our ARB is similar to triangle CDB. So we can set up that proportion. Now X is in AR, and we also know the length of AB. So we're going to use those as our comparison. So AR over AB. The corresponding side to AR is CD. The corresponding sides to AB is CB. So now we substitute in the values. So the length of AR is X, the length of AB is 180, the length of CD is 75, the length of CB is 90. Now we cross multiply. X times 90 is 90x equals 180 times 75, which is 13,500. And then we'll divide both sides by 90. So X is 150, so the length of AR is 150, and everything is in meters, so 150 meters. So we're setting up a lot of proportions based off similarity here. Now let's review a concept we took a look at yesterday, and that will come into problem 3. So 3, you're told to find the distance across the pond. Rita climbs a 30-foot observation tower on the shore of the pond. So here's a 30-foot observation tower, and locates points A and B so that AC is perpendicular to CB. So we have a right triangle here, that's what it's saying. She then finds the measure of BD to be 12 feet, which is labeled. What is the measure of AD? The distance across the pond. So here we're going to be using the property we looked at yesterday. So CD is an altitude of this triangle since it goes through an angle and creates a perpendicular segment to the opposite side. So we know we have two similar triangles here, or actually three here. We have the larger one, and then we also have the smaller one. So ACD is similar to triangle CBD. So here we can set up a few different ways. So we can do the longer side of triangle ACD. So this one right here. So that longer side is X over its shorter side of 30, and then set it equal to the longer side of the triangle CBD. So that longer side is 30, the shorter side is 12, and then cross multiply. X times 12 is 12x, 30 times 30 is 900. Divide by 12, so x equals 75. So the measure of AD is that x value, which is 75 feet. Which, keep in mind, you can check to see if that makes sense. Since the shorter length of that leg is 30, it would make sense that x would be greater than that. So that's another way you can assess to see if your answer is correct. All right, the last problem today is problem 4. To estimate the height of an overhang, a surveyor positions herself so that her line of sight to the top of the overhang and her line of sight to the bottom form a right angle. What is the height of the to the nearest tenth of a meter? So we're finding this distance here. So we're finding the length of BA. Now here we'll also be using some similarities. Since we're given the lengths of some shorter triangles, we'll be using those smaller triangles. And let's call the length of the overhang from B to A, let's call that X. So since that's X, the length of B to D is going to be X minus 1.75, since the length of DA is 1.75 meters. So we're going to set this up. I'm going to use these two smaller triangles to set up. So I'll shade them in different directions. So I know the longer length, X minus 1.75, over its shorter length of 8.5, equals the longer length of this bottom triangle, which the longer length is 8.5, over its shorter length of 1.75. Then we're going to cross multiply. So we get 1.75x minus 3.625 equals 8.5 times 8.5, so 72.25. We'll add 3.0625 to both sides, get 1.75x equals 75.3125. Then divide both sides by 1.75. So x equals 43.0, since that's the nearest tenth of a meter, we'll round to 0. So the height of the overhang is 43 meters. Now keep in mind, since I defined BA to be x, and the long length here, DB, is x minus 1.75, we don't have to add on that 1.75 because it's already accounted in that x value since we subtracted 1.75 from it already. So the x value is 43 meters. Your homework is going to be a sheet the substitute will have for you. We'll be turning in the homework from Monday and from today tomorrow, or Wednesday, and we'll be reviewing that as well. Hope you have a great day, and I will see you tomorrow.